It's not really a weakness of Go, but we have some opinions around like what a Go API should look like at Clever. In some cases, we've ended up building kind of edge casey APIs that have like, non-JSON HTTP interfaces, basically. There were a few times where that was more convenient. For example, we've done a important SAML service is not written in Go, but we would love to move all of the important business logic to Go. So yeah, that's kind of my philosophy is like, we want the Node TypeScript layer to be as thin as possible.
Bandwidth for Changelog is provided by Fastly. Learn more at fastly.com. Our feature flags are powered by LaunchDarkly. Check them out at launchdarkly.com. And we're hosted on Linode Cloud servers. Get $100 in hosting credit at linode.com/changelog. What's up, Gophers? Our friends over at Gravitational made a big transition at the end of 2020 to rebrand as Teleport and shared a new product announcement to showcase the direction they're taking. Teleport is operating from a vision of being able to run and access software anywhere in a secure and compliant manner, something they call environment-free computing. With Teleport, engineering teams can quickly access any resource anywhere using a unified access plane that consolidates access controls and auditing across all environments, infrastructure, applications, as well as data. Teleport server access lets you SSH securely into Linux servers and smart devices with a complete audit trail. Teleport Kubernetes Access lets you access Kubernetes clusters securely with complete visibility to access and behavior. And finally, Teleport Application Access lets you access web apps running behind NAT and firewalls with security and compliance. Try Teleport today in the cloud, self-hosted, or open source. Head to goteleport.com to learn more and get started. Again, goteleport.com.
Let's do it. It's go time.
Welcome to Go Time, your source for diverse discussions from around the Go community. We record the show live on YouTube. Join us every Tuesday at 3 p.m. U.S. Eastern Time. Subscribe at youtube.com/changelog to be notified and chat along with us in the Go Time FM channel of Gopher Slack. Okay, let's do this. Here we go.
Hello and welcome to Go Time. Today I'm joined by two members of the team at Clever, and we're hoping to discuss different things about how you're using Go at Clever, like why you started using Go, different challenges you had, and hopefully a lot more. So our first guest is Rafael Garcia. He's the co-founder and CTO at Clever. How are you doing today, Raf?
I'm good. How are you?
I am good. And our second guest is Nathan Leiby. He is an early engineer at Clever. How are you doing, Nathan?
Doing well. Thanks for having me.
Thanks for joining. So, I guess the first obvious question is, when did you start using Go?
We started using Go in 2014, March of 2014. The company itself was founded in 2012, so a few years in, we were feeling a little bit of the pains of kind of the tools and tech that we were using at the time, and Go kind of found its way into our stack and found some early success back in 2014. So I guess it's been 6-7 years now.
What were you using before Go?
This is where I get to talk about embarrassing initial technology choices. The first kind of stuff we did was in CoffeeScript and Node. So back in 2012, that was a popular choice. And yeah, we were primarily building an API, and that was basically the only surface area of Clever for a long time. And there was a lot of stuff that started to get a little bit unwieldy. I felt this a lot as we started to hire more engineers, just like onboarding engineers into the mess of a CoffeeScript code base that I had been primarily responsible for was tricky. And so trying to bring some more, sanity to that, Go ended up being a big contributor to more success there. But yeah, we were basically feeling the pains of an untyped language running on a single thread, doing like data processing and API, like high performance API responses. That's kind of the short story.
That makes sense, especially because as a startup, I think sometimes just being able to move quickly is important. And, JavaScript can be really good for that. But then there's definitely times where that starts to bite you a little bit and you need a little more structure, especially like, as you said, as you're scaling up your engineering teams. That's where I think if you have any sort of like confusion in your tech stack or anywhere where things can go wrong, it's when you start scaling up your team, I feel like is when it tends to start to show itself, because it's not just a couple people who really know the code. You have to actually have something that people can jump into. So you said that you started having some successes with Go. Like, how did that start? Like, what was the first thing that was written in Go, or how did it end up in your team? Because I think sometimes people want to like go out and pick a language and rewrite everything, and I'm guessing that's not what you did. So what were those first projects like?
One of the big initial projects we had, as we grew, we needed to start placing some limit. So at its core, one of the big things that Clever does is an API for other software companies to use. As we grew, we needed to place some limits on that. And so we put a rate limiter on our API that is called Sphinx. It's open source. It's basically a proxy. And there were some interesting problems there, how to run it in multiple instances that have shared state about where people are in their respective rate limits. And so we took a bet on Go, and the team was enthusiastic about trying it. And the standard library had good support for just straight reverse proxies. So we went for it, and it's been great. And I think, one of the early signals we got on Go at that time was like, it doesn't require a lot of babysitting once you have something running smoothly in production. And so that started to kind of connect the dots for the team that, like, as we start creating things and putting them out in the world, like, we don't want the overhead of having to operate them and have to think about them after too much after we've put them into the world. And so Sphinx has been that for sure. We still run it. We rarely have to think about fixing bugs or doing other things with it. And yeah, that was kind of the first step back in 2014 was that project. And then, yeah, Nate probably has lots of perspective too from joining the team and jumping into some of the messes that were created.
So you said you took the bet on Go. I'm assuming this was something that realistically, if you needed to pull it, like if Go didn't work out, I'm assuming this was something small enough that you could have pulled it out and replaced it with, a JavaScript app if you needed to.
Yeah, I think there was enough enthusiasm on the team, and I think we went into it knowing that, we might have to throw all this away and go at this a different way. But sometimes you have to take those risks, and it pans out, and you find a new tool for your tool set that, pays dividends for the team. So that's kind of what we did. And there are plenty of stories of us, taking bets on other things that didn't pan out. So you win some, you lose some, I guess.
Yeah, that makes sense. And hopefully we'll get into this more, but one of the questions we hear a lot is, how do I get my team to transition to Go? And I think that, like, what you gave is a classic example. If you pick a relatively small, isolated problem where it's a good test case and see how it goes, and if it's successful, then great, and it was a good bet. But if it was a bad bet, it's not like a company killing bet at that point. Nathan, do you want to share some of the other projects that you guys jumped into early on? Yeah,
I was just thinking about a different part of our stack. So another big thing that Clever does is integrates with a lot of third-party systems. So whether web scrapers or API integrations, just a big part is like extracting data. So another early place we started trying out Go was to build some of those data extract workers. And I think that it was a couple of months after I had to look at our Git commits to figure out exactly when, and I think that went actually through like a spec process. We're like, okay, we want to build this thing. We wrote a doc. We're like, here's what we want to build. And then at that time, it's been a few months in to go, and we're pretty confident it would be a good way to build this. We mentioned CoffeeScript, but we actually had a lot of stuff written in Python as well to do some of those extract jobs. Not strictly a bad language for it, but in this case, we were working with like a schema API. It was easy to think about how we would write that data extract logic. And I think there we were really testing like, what is the development and collaboration process in this language? It was less of like, I don't know, the other thing was like experimental, and this was like really getting it into our real dev process.
And seeing how it works with the whole team.
Yeah, I think, 2 people were collaborating pretty closely on this project, but it wasn't yet a huge thing, but we were starting to reconsider some of the abstractions we'd already built in Python. For example, we had kind of a worker abstraction about how you like receive a job and do some work and write an output somewhere. And we were like, well, what if we rewrote that abstraction in Go? What if we had a way to consume jobs? And then additionally, of course, all the data ingest logic. How would that work? So I don't know. It was pretty smooth. That is also still live many years down the road. I think we started seeing some of the how you write tests in Go, the benefits of having types that really started making the language more appealing.
Did you, like you were testing to see if it worked with your team, obviously, and to make sure the projects worked, but were you looking at other things like, like how often you had bugs in production? Like were any of those things on your mind as you were trying Go out?
Yeah, I mean, I don't know how formally we're measuring all of them, but we were definitely responding to pains we felt. I think this project in some ways was like a well-structured project where we thought that some bugs we would face would be like network-related stuff that Go really wasn't going to solve. Like the system we're extracting data from is down, although maybe we learned about error handling and other things there. But I would say that immediately jumping into a tool chain where tests are like a key part of that's exposed by the language easily, and there's no like debate on which testing libraries to use or how to build them, immediately was beneficial to us. Whereas I think maybe that's the company maturing too, starting to do more kind of test first development. But I don't know, we saw wins there pretty quickly, I think.
Yeah, that makes sense. I know I did a lot of Ruby before I switched to Go, and one of the things that always killed me was I didn't really care for RSpec, but it was the most common library for testing, so I almost had to just suck it up and learn it and use it because you were going to run into it in some company or some project or something. But on my personal project, I used something else, and I kind of switching to Go. It was nice that everybody used the same thing because I didn't have to do those mental switches or anything. It was like, this is just the way we're going to test, and it makes sense, and it's pretty easy. I don't know if you guys had the same thing, but one of my experiences switching from like a Python Ruby type language to Go was that I felt like testing was almost easier because having a type system and everything there just, I don't know, for me, it made it clear like what sort of things I wanted to test versus which sort of things weren't really worth testing. With type safety, you don't have to test like what happens if we pass in the wrong thing. Like there's all sorts of cases you can kind of just ignore and just focus on the important tests.
Yeah, I think we definitely felt a lot of that. And I think another thing that comes to mind is just like we're coming from Node, where to do anything non-trivial, you have to pull in like tens, if not more third-party libraries to do things like testing, to do like any non-trivial application. But with Go, at least I think for a lot of the use cases we were working on, you rarely had to do that, to dive deep into the third-party ecosystem, like the standard library for testing and for writing, HTTP services was sufficient. So yeah, it made things a lot more straightforward. And yeah, definitely like on the testing front, like interfaces and other things like that, where you're testing actual functionality and not like, the various values that a non-typed variable can take in a untyped language. It definitely simplifies the story.
I think the other thing for me was always that because in dynamic languages, it's so easy just to replace anything that you end up writing tests where like you almost like throw a mock in certain places and then you're like, well, does it get this input it's receiving? Whereas sometimes in Go, you can do that if you really want to try to, but sometimes it's hard enough that it's like, is that actually worth it? You like have to stop and think about it. So you had mentioned that with the Node world, you had to pull in a lot of libraries. Do you think that's gotten better in JavaScript? Or if I rephrase the question, if you started using JavaScript today, like from the ground up, do you think you would have been as quick to transition to Go in a couple years?
Yeah, that's a tough one. So, I mean, since 2012, things have come out that have changed the story. We use TypeScript now, and that has significantly helped in the realms of like just making the code base more approachable for new team members, or if you're switching onto a team or something like that. I think from a general development point of view, I think there's still kind of a mess of third-party libraries that you have to wade through that is a little bit frustrating at times. But to be fair, I think the vast majority of the stuff we do in Go is not web apps that require, a build process to create front-end JavaScript and like communication between a browser and a backend. It's the vast majority of our Go services are backend services that just need to worry about doing HTTP requests. It's kind of an apples to oranges comparison for us, at least. I'm sure if we did a bunch of web apps in Go, we would have probably a lot of complaints that look similar to the complaints I could make about Node and TypeScript.
That makes sense. So you said you're using TypeScript now, which I assume means that you're still using JavaScript and, or TypeScript, I guess, but JavaScript for some of your stuff. So you didn't just rewrite everything in Go. So do you want to talk, I guess, a little bit of, I guess the first question is, how much of your code base do you think is in Go at this point?
So the general structure is like any front-end web app, for the different users that use Clever is a Node TypeScript app. And then underneath the hood, those apps communicate with a bunch of services that are internal. And you can basically say all of those are Go. And so in terms of the backend infrastructure, probably you could say 90% of it is Go. And, the 10% that serves a web app for various user types is Node. And yeah, I think maybe one area where we haven't had success is in creating internal apps that are Go web apps. And it's been an okay process. We haven't invested all into doing it, and trying to figure out the best process for it, mainly because, there's not a burning need to rewrite everything and get everything onto it to Go or not. So I don't know. Nate maybe has some more thoughts on this. He's probably done more front-end stuff lately than I have.
Yeah. Well, my sense is just that the tool chain for developing something with sort of an Express server that's pretty spare, but kind of serves whatever server-side code needs to be executed. And then through the React environment, ecosystem, all of that, you can just run the whole thing in TypeScript. Then the goal is just remove everything involving logic or databases. So it's all that is Go. You're just calling out to another service, and that's sort of our microservices split. I've also, it's not really a weakness of Go, but we have some opinions around what a Go API should look like at Clever. And so in some cases, we've ended up building kind of edge casey APIs that have non-JSON HTTP interfaces, basically. And there were a few times where that was more convenient. For example, we've done a SAML, important SAML service is not written in Go, but we would love to move all of the important business logic to Go. So yeah, that's kind of my philosophy is we want the Node TypeScript layer to be as thin as possible or to serve entirely UI kind of needs.
That makes sense. In the past, we've talked about some things like building a GraphQL server in Go is something that it's not too bad from the server perspective, but if you're trying to make a client in Go, that can be really challenging because Go doesn't really lend itself to this, fields can and can't be there at times. That's just not Go. So there's definitely cases like that where it does not fit, and when you get into something like TypeScript, it can be much easier to work with because it's just it's designed around that almost. So you said that you're split up and you have your web UIs are written in TypeScript or the Node world, I guess, with Express and some of those things. What is your overall structure like? How do those, do you have microservices? Do you have one big backend server? Or what is your overall architecture?
Overall, I think I was looking the other day, we have somewhere north of 200 repos, and each repo is roughly corresponds to a service. But a lot of them, I guess the primary request path set of services probably numbers in the 20 to 30 range. So we have the handful of web apps for different user types. And then you can think of it as tens of Go microservices that power the primary request paths in there. And then a whole bunch of background job processors with singular purposes and various kind of duties to perform throughout the course of the day. So syncing data from third-party systems, running analytics kind of stuff, and other stuff that isn't triggered directly by a user doing something on the web.
So with that many repos, to me at least, that sounds like a nightmare to manage or to go about, just because I'm thinking in my head, if I want to make a change that touches 3 repos, what does that deployment process look like? How do you manage that? And how do you make things feel consistent as a team? Because at least for me, one of the big benefits of Go is that a lot of Go code feels the same, but I worry that if you had that many repos, you could potentially have services that look very different? Do you use like, I guess, some sort of generation or anything like that to make that look consistent?
We standardized pretty early after some painful growing pains with Thrift on Go doing kind of HTTP JSON APIs. So every service now has Swagger Open API definition file. We have CodeGen that it's this thing called WAG. It's open source on our GitHub that generates a Go server, a Go client, and a Node or JavaScript client. And then, from there, there's a ton of consistency across all of those repos. And I think we were lucky in some sense to do that fairly early on because, we could be in a world where there's lots of inconsistencies and jumping around would be difficult, but it's actually not that bad. I think some of this also goes into like when to create a service because, it would be a tragedy, I think, if like to do something basic in the product, you had to touch, 5 or 6 services and roll out changes and make pull requests, get them reviewed and all that. But I think with a modest approach to microservices, you can kind of isolate features or things that need to be changed. The number of services is usually not something north of 2 or 3. There's a lot of services, but we've put some thought into standardizing, and then we also have some tooling as well to manage some of that.
So it sounds like you're conscious of the fact that you don't want to split into so many microservices that it's obnoxious. So how large do you think an average service is for you? Are we talking like 100 lines of code where it's like this tiny thing, or are we talking a couple thousand lines? Like, what does an average service look like?
The way I think about it is more around, how large of like a product surface area does this service work with? Mm-hmm. So there's kind of 2 key types of microservices we run. And I guess I'll distinguish one thing. So a service to us is sometimes, like this HTTP API, but also I don't know whether you think of our workers, the like data transformation things as microservices as well, but you might if they're saying they do like a single small task. But anyway, from the API layer, I think it's often like, I need to build a new product feature. It stores like pieces of data and configuration. Generally, that's one service around a product feature, and there's a data store associated with it. So really concretely, like, I'm building a new, like, totally new area of our product called analytics reports. Okay, we'll probably build our own service that contains the data regarding those. And if you need to, like, a user needs to set configuration for themselves, that would go through that service. But if someone else is then going to add a new feature on top of that, like a small incremental improvement, then they'll just add it to that existing service. So anyway, I don't know. I think of more like what product abstraction is often an important thing. There are definitely times where you might slice a microservice based on performance considerations as well. So maybe Raf, do you want to talk at all to like how we've split up SSO and thought about microservices there?
Yeah, performance considerations for us kind of boil down to what would trigger downtime. So we track pretty closely kind of our uptime and try and maximize that as much as possible. And so one of the strategies we use is for services that are in the core like request path that we call SSO, single sign-on is kind of the core feature of Clever that needs to be up all the time. We split that out into its own kind of deployment path so that all of the requests that are hitting those services are from actual users trying to log in essentially. And so we've split those services up and thought kind of carefully about their performance requirements and uptime requirements. And we don't want like background jobs, like hitting them with these massive queries that might bring them down or kind of change their performance requirements or make them just hard to satisfy from the service's point of view. So yeah, some degree of carving out these like swim lanes of like, here's a use case that we want to isolate and really protect from just like uncontrolled requests from anyone spinning up a new background processor or whatever.
That makes sense. So when you're looking at these microservices and setting them up, do you have like, is it generally like one engineer sort of owns a single service, or is it something a little bit different? Like, how do you approach that aspect of it?
Yeah, like Nate described, it's really feature based. That boils down to like team based. So, someone on a team responsible for a product area will spin up a new service, and we initialize it with various pieces of metadata, including their team. And that's kind of where the ownership bit gets set. And then, from there, that team, like the owner of that product area, is responsible for the service. We do have some degree of like individual ownership tagging so that, if someone feels like a strong affinity towards kind of how the code is set up in a particular repository, they can get pinged on pull requests and things like that. But ultimately it's teams map to repos, which map to services.
What's up, Gophers? Are you trying to take your infrastructure further, faster? Of course you are. On March 3rd, join Equinix Metal for their first technical user conference called Proximity. Proximity is a follow-the-sun day of live-streamed technical demonstrations showcasing Equinix Metal's partners and their ecosystem. Visit metal.equinix.com/proximity to view the schedule for this event and get closer to your digital advantage. Again, metal.equinix.com/proximity.
Taking a step back, earlier you had mentioned, I think it was WAG. Was that the library you built? So for whatever reason, I feel like this is not an uncommon thing where people build a service that sort of generates either something from Swagger, or like Matt Ryer, who's sometimes on the podcast, wrote, I think it's called Otto, which allows him to create sort of an interface, and then it creates a Go HTTP server, but then it also creates like a JavaScript client that communicates, via HTTP JSON. And the idea is sort of to write one definition once and then generate the code on both ends for communicating. But I guess what's interesting to me is that it seems like a lot of times people build that themselves rather than using some standard that's out there. So in your case, did you not land on the Swagger like whatever tools they have because they just weren't up to par at the time? Or was it something where you had specific needs? Or can you, I guess, elaborate on why you built something yourself?
I think generally speaking, we try and utilize as much as possible existing tools. One area where we've learned where we need to have more degree of control is in that final, like last mile kind of touch point of engineers on the team with whatever it is. So in this case, it's like you want to interact with a service in our infrastructure. We really wanted to have control over that, like down to like the method signatures and like, the interface that's generated, things like that. And at the time, the Open API or Swagger, as it was called back then, Go generation was pretty young and not really pluggable. I think now it has some degree of like, you can plug in your own templates and other things like that. It still requires a decent amount of investment to like get it to do the thing you want it to do. But ultimately, we had a pretty focused use case. And we also actually still use an open source Swagger generator for types and some of the nitty gritty stuff that we didn't have a specific like divergent view on, I guess. It was really about like the interface for the client and the server, kind of how the HTTP request gets handled, where we wanted to have control there. So it was mainly about just, finding the parts that we could just use out of the box, but then like having enough control where we could iterate and do things that we wanted to do without having to like wait on a pull request or like really fork and modify an existing thing and have to maintain a fork and do all sorts of stuff like that.
I think you also had an important point where even if you're using one of those open source off the shelf tools, like you said, to get it to do what you want in some cases, you have to customize it so much that it is a big investment. And by the end of it, it's almost not like you're using an off-the-shelf tool anymore. You're using one that's so customized to your workflow that people joining your team still have to learn something new regardless. At least that's what it seems like to me in some cases, where if they can't just come in and be like, oh, I've used Swagger, I can jump into your code, then sometimes it's not really worth using that tool.
Right. I was actually just looking this morning at Datadog's API, and they generate their Go client using the Open API generator, and they've built a whole framework on top of the OpenAPI generator for customizing the OpenAPI generator. So it's like all paths lead towards like you writing a thing that gives you the control you need.
It's a weird thing because I feel like as developers, because we know we can control it and get it exactly the way we want it, we don't want to settle for something that's subpar, especially when it comes to like having an entire engineering team, actually being efficient with their jobs and getting things done. You don't want people to be doing silly things all the time.
Sometimes it's worth building that extra wrapper to actually reduce the capabilities of a tool. So what I mean to say there is maybe you don't want people to use all the edge case features that exist in Swagger. And so it's actually quite nice to limit things and have your own wrapper that does that. I realize maybe it's for safety. Maybe it's just to simplify your system. Maybe you make a decision later to re-enable one of those features, but I think that is powerful.
Yeah, that definitely makes sense. So like a question I hear a lot when people are jumping to Go is they talk about like migrations, like what tool should I use for these migrations? And I think that stems from people using like Rails or some of those frameworks that have really good migration tooling built into them. And then when they get to Go, it's kind of confusing because that doesn't usually exist. And I think sometimes people forget that a lot of those edge case tools, like they are a double-edged blade where they can help you and hurt you just as much. So sometimes keeping it simple and just writing something on your own that doesn't have them can be easier, at least in the short term.
For sure. You might lose out on some long-term benefits. So we want to leverage the open thing as much as possible.
Yeah, that makes sense for sure. So you've got all these microservices, and you've kind of alluded to the fact that each one will sort of have its own data layer. What does that look like? Because I think for a lot of people when they're building an application, they think of, I've got my app, and then I've got like one SQL database that has everything. It sounds like that's not the case here. So can you, I guess, go into some details as to like how you interact with data and like what those services are like?
Sure. Well, it's definitely something we've invested in more over time. I think from a sort of resilience perspective, we wanted to move toward a world where one service talks to one data store so that you don't get a lot of confusing request patterns on your database. So it's like, how do we actually do that operationally? The biggest success we've had is that we've put a lot of automation into spinning up Dynamo instances mostly. So it's very easy at Clever to create a web service with a backing Dynamo data store and have all the code auto-generated, except for some specifics of your controller logic that are relevant to your specific app. Like everything else, the web interface to send those requests, the actual code that writes to the data store and retrieves data from the data store, the actual spinning up of the DB, the ability to modify the scale of the DB, all of that is pretty easy to do through minor configuration changes and highly automated. So that's kind of the best case scenario if that serves the needs of your app, which it doesn't serve every app, but it is quite a convenient way to bootstrap projects right now.
Do you do something similar for like the rest of the project? Like you're saying like the DynamoDB, it's pretty easy to spin that up, but if somebody wants to start a service, do you have like templates or code generation or something for an entire service?
Yeah, so all the engineers at Clever, there's a CLI we have that does things like deployment, but it also has the ability to initialize a new project. And that involves both the code template. So for example, I want to make a web service in Go. There's a template for that, a WAG-based web service. So you'll say you initialize it, it'll spit out a bunch of code, and then you're going to have to, fill in a few, like the post handler should actually retrieve this object and write it to Dynamo. And while it does that, maybe you need some business logic added in there. But pretty much everything else about a service is already done for you. So, how you receive the data and marshal it, how you validate it, that's all Swagger stuff. And then on the database side, it's like how you initialize a connection to the database, how you do writes to the database. So a huge amount of it is there's a template that sort of abstracts over what is a web service, and then there's a lot of generated code that supports the things you need to do with that web service.
That makes sense. You mentioned a CLI. Is it written in Go? The most important question.
It
is.
Did you have CLIs like that written in Node before?
No. Well, our main infrastructure tool before this was written in Python. And that was mainly because we are still doing a lot of like AWS interactions, and Bodo was a good library for that. But yeah, the primary tool now that engineers use is a tool that is written in Go, which is actually interesting from the perspective of we build binaries for macOS for people not in macOS. And yeah, there's some interesting features there. And simply just packaging a binary is way easier in Go than, installing something Python always is a adventure.
When I've talked to people in the past about how they got started with Go, it seems like that's a really common use case is if you need a CLI in your organization, that Go is a good spot for it because it's something that if you need to replace it, it's not going to be detrimental to the entire organization. But it's usually one of the cases where Go shines pretty well because if you have people, like you said, on different operating systems, it's nice and easy to bundle it and actually send it to them versus I think anybody who's tried to use a CLI in another language where you have to install these things and like hope basically that it works, that you've got everything set up correctly. Because if it's not, then it's going to be pretty tricky.
Yeah, I feel like my Python installation is never in the right state whenever I go to install something. So I'm grateful for the Go binary approach.
I just ran into that recently where I was installing software that I use. It's called Softcover. It's written by Michael Hartle. But he has like a big Rails tutorial thing, and he made some software that makes it easier to sort of generate an ebook out of a Markdown with a little bit of LaTeX mixed in there. And you have to install all this stuff to get it to work. And I got it all installed and set up and rebuilt the book that I have and was doing all that. And then I went back to my blog to build it, and it had somehow, in that process of things being built, that had changed whatever software was being used there, like some third-party dependency. And like just having that issue where you almost have to, like, depending on what you're building, you have to go fix your installs for everything. And it's kind of a nightmare versus just having a CLI that you're like, I can run this and it works. I don't have to worry about that.
Go has certainly gone through its journey of dependence, package managers, and that's a different story. But the ability to share the binary once it's done works amazingly well. So, and our infrastructure team, I was going to say, has loved using Go for all kinds of just kind of convenient internal use cases. I think that was a big adopter beyond sort of the APIs and data processing stuff, which is internal tooling. So it's been nice.
So speaking of, have you guys, like, what is your experience with the Go mod and that sort of thing been or have you transitioned to Go mod, and like, what has your experience there been like?
Yeah. So one thing we've really liked about Go has been, it's been pretty reasonable for us to upgrade from version to version and from, dependency tool to dependency tool. I don't have like a detailed perspective on Go mod because it's worked for us really well, I think. So we have some abstractions around how we build stuff in Go. So we have a golang.make file. We use make as our sort of primary way to do automation, both in Go projects and non-Go projects. And so, for example, you might have had a step that said make dependencies that formerly, ran GoDep or whatever else. And, subbing in Go mod there worked great for us. I can't think of any issues with the latest iteration.
That's good to hear because, like, at least sometimes it feels like all you hear is the bad news because generally if things are working, you don't say anything. So it starts to sound like, oh, this thing isn't working at all. But in reality, for at least my experience has been that there's a good chunk of people that Go modules works pretty well for. And then there's the subset of cases that it doesn't seem to work as well for. And those people are rightfully upset and frustrated at times because, you want to get back to work. So you talked about upgrading versions. And you have hundreds of repos. What does that look like, I guess, whenever you're trying to manage that many repos? Do you just do them one at a time when they need it? Or what does that process look like?
Nathan and I, we actually worked on this. There's a hackathon maybe a few years ago where we recognized that this was a problem. And so we created this tool. It's open source on our GitHub called Microplane. And essentially what you do is it works you through kind of a workflow of you first search for the repos you want to modify with like a GitHub code search input. It takes care of cloning those repos onto your machine. And then you give it a script to run that you want to apply and run in each of those repos. And then you can instruct it to additionally push it to GitHub, open a pull request, assign it to someone. And then eventually it also will take care of merging those pull requests as well. So it kind of is a workflow tool, I guess, in some ways, to making changes across tons of different repos. The challenge ends up being, can you write that script to do the thing you want to do to every repo? And so that's where things like, standardizing on a make file or like a build process for Go repos is critical. Having the same dependency management across all repos is important. But yeah, we've used that. So for the example of like updating a Go version, there are a few places where the Go version appears in a repo. It's like the make file, the CI, like Circle CI config, and maybe that might be it actually. And so it actually ends up being pretty easy to write a script that just finds those lines and changes them, and then farms it out to GitHub for review, and then we just have to merge it all. So it works pretty well but then there are obviously cases. We're running into this now, moving to GoMod, where some of the devils are in the details. Like it might not be possible to automate all of those conversions, and there's extra work that needs to happen. But for a lot of the easy change a few files here and there across all repos, Microplane has been pretty useful for us.
Yeah, another thing that comes to mind is I do feel like automating changes on repos is part of a growing trend. So it's kind of cool to take an opinion on how to do that and see people honestly doing it better. So for example, Dependabot is something that GitHub is investing in to think about how do you automate dependency updates across all your repos. So yeah, I mean, updating like a Go, like a package file is one part of the problem, but honestly, I think the future is, refactoring your whole repo to best practices automatically or continually writing your code for you better and better. And so some of the other hard parts that come up in our current process, we'd have to build fails. So you made some change and there was a breaking change. Well, we have to assign it to the right person and make sure we have a human process to deal with that. So that's part of what Microplane is doing. And the other is, okay, we changed the code. We thought it was safe, but now we're going to ship it. Are we sure that's a good idea? So, I mean, a lot of effort we spend at Clever with microservices is how do we deploy stuff safely? So, how do we have consistent alerts across our services? How do we automate deployment? While you're in an automated deployment, how do you understand if anything's going wrong and, roll back quickly, get the human in the loop if they need to be there? So I would say that's sort of a supporting piece of running many services is just, rather than thinking about how to automate a complex, huge monolith being deployed, we need to think about automating deployment of 10 things at once or 50 things at once and making sure that's a sane user experience where you can debug failures.
Has that been something that you've developed incrementally or yourself locally, or using off-the-shelf tools for that? What is that deployment process? Is it something that it's just yours?
Yeah, we basically have a Slack bot that behind the scenes is running a state machine that represents your deployment. This is definitely something where I'm sure there are other tools out there that we could leverage more heavily. When it started, it was very straightforward. It's say yes if you want to deploy or something like that. And over time, it's become much more of a feedback loop where you're getting a Slack thread describing, whether it looks like something is going wrong or, a canary is happening right now and maybe a full deploy will happen in a few minutes. We definitely looked at other existing systems. I mean, part of the challenge was we saw people doing cool work, but, running Netflix's Java system to do this just wasn't worth it. And I know Kubernetes also has done decently well with this, with having lots of tooling. I mean, we didn't build on top of Kubernetes. We're mostly on ECS. But anyway, the deployment abstraction for us is not like Kubernetes, so we can't just reuse that set of tools either.
This episode is brought to you by LaunchDarkly, feature management for the modern enterprise, power experimentation in production. Here's how it works. LaunchDarkly enables development and operation teams to deploy code at any time, even if a feature isn't ready to be released to users. Wrapping code with feature flags gives you the safety to test new features and infrastructure in your production environments without impacting the wrong end users. When you're ready to release, more widely simply update the feature flag and the changes are made instantaneously by the real-time streaming architecture. Eliminate risk, deliver value. Get started for free today at launchdarkly.com. Again, launchdarkly.com.
I feel like that's a pretty common pattern to, it's not hard for you to end up with a homegrown solution, I guess is the way I'd put it, because like you said, you usually start with one small thing and then you just need one more small thing, so it's easier just to add it, and eventually you've got something so custom that trying to make other tools work would have been hard anyway. And I think that's one of the areas where people, at least when I talk to people who are talking about, I want to learn microservices, I think that's a huge part of it, is they want to understand, how do I deploy this and manage this? And it is a challenging problem. I don't think anybody has all the answers to that at this point.
Yeah. And I think another thing too is like, you have to accept that like the underlying bits and pieces will change as well. So like Nate mentioned, like we kind of have this automated deployment process that goes through this kind of state machine of like the various phases. And, initially we wrote that state machine ourselves. Like it was a service with like some like data base behind it that we kind of went through the motions of ticking this state machine through the different transitions. And then we started getting more proficient using AWS's, like they call it step functions. It's like their state machine runtime basically, and switched to that. And now like the surface area that we actually maintain is that much smaller. We change our deployments to now span multiple regions of AWS. And so, we need to expand either the state machine or like the thing that it's interacting with, making these types of changes and evolving the underlying system gets a lot harder if you've kind of really forced some other piece of technology to do something for you in a way that can't be changed. So yeah, it's a tough balance. The failure mode is, you create all these things and now your surface area of what you need to operate and maintain is so large that it's hard to, you kind of fall under so much weight of that. And so you kind of constantly have to be thinking about where can you kind of factor big chunks out and effectively like have some managed service or open source library or something do it in a much more efficient way so you can focus on continuing to build. That's really where the challenge, I think, looking forward is.
So given that you need a process like this to deploy, and there obviously are a lot of moving parts when you've got this many services, what does local development look like? For instance, if I wanted to run the tests, do I need to spin a bunch of things up, or did you build tooling around that as well? Or, even just like if I want to run the whole app locally, do people run the whole app locally or do they just run small parts?
Yeah. So the approach that we've taken, it did change over time. I think at first we tried to run several things locally and quickly realized that, it just takes too much time to spin up, or you have to make sure every single one of those applications is in a good state locally. So where we arrived is that we basically have the ability to run a single microservice or the one thing that you're changing actively locally, and then point to everything else in a staging environment. We have the ability to run a unique environment per user. So for example, I could run one called Nate and he could run one called Raf, and they'd be totally isolated from each other. In reality, that hasn't really been as useful as we thought it would be. We basically end up having one large shared staging environment that people reuse. Partly it's practical. It's less stuff to be running, less data store copies and things like that. So yeah, I would say you run one application locally and you point to a shared development or staging environment for all the other dependencies. The main downside with that is, if multiple people are actually actively trying to change the same thing, could that cause issues by having a shared staging environment? But it offloads all the effort. Even recently, I've done some side projects with the Docker Compose file, and I'm like, this is too much work. Even for a handful of services, like everyth's always breaking somewhere. I don't know. I mean, it is like a side project, so it's not the same level of love that a company that's invested in Docker Compose might have put into that. But anyway, I'm really grateful that you could just like run something, and you're only really worried about your one local thing, at least 95% of the time.
It makes sense. I mean, I use Docker Compose for some things, but my general feeling is that it's almost like you need somebody in your team who really understands Docker and Docker Compose if you're going to go that route. Because at some point you're going to have issues and somebody's going to have to be like, well, why is this happening? How can we fix it? And you can get so far by yourself and just figuring it out. But at some point, I feel like you do run into those issues of how do I address this? I take it that also means that people have to have an internet connection to development. Is that the case? If
you're developing the stuff that needs to talk to web services, then yes. But certainly I would advocate for, you should be writing pure local stuff as much as possible. So if you're writing business logic, do you really need to talk to the remote thing? And, how can you use better like dependency injection or mocks to simulate that properly? But yes, if you wanted to, for example, spin up a UI and click through it, you would need to be connected to the internet.
Okay. And then I take it that means that most of your tests are sort of isolated to individual services, and do you run tests that touch everything, or is that like, I guess you could just say like a QA environment to do something with the whole thing? And do you only run those in like a QA environment? Or I guess what does that process look like?
Tests in an individual repo or service will be isolated to that service, its business logic, and maybe its data store. But for services that are part of a bigger piece, like a particular product, we do have a CI process that gets triggered that spins up, like Nate said, isolated development environment or staging environment with your change, and then tests some end-to-end flows. So, if you, for some reason, the interaction that other services have with your service that you're making a change to, if you break something there, it'll get caught in CI when that kind of end-to-end test gets run. So yeah, some kind of automated QA, I guess, is definitely necessary in this world, because you're pushing out, one piece of a bigger whole that, needs to get a kick of the tires to make sure you haven't broken anything.
Okay, I think it is time to jump into our unpopular opinion segment.
I actually think you should probably leave.
Do either of you have an unpopular opinion you'd like to share? It can be about tech or not about tech. That's completely up to you.
I'll take a wager on a Go one, but now that I started looking at who's on this podcast, I know they're way better at Go than me. But anyway, my unpopular opinion is that, Go channels aren't worth it. After writing Go for 7 years or so, I have probably used channels a handful of times, and the majority has been, to use a time ticker or something like that. So I'd prefer just the sync package to solve pretty much all my needs. I know they're elegant. I know they solve something useful. I know they're philosophically great, but I've rarely found code that was easier to read with them.
If it helps, we did have, I don't remember, maybe it was about a month ago, we had an episode where one of them, I think it was a member of the Go team, actually said that channels are kind of a foot gun, where more often than not, basically people shoot themselves in the foot with them than actually get what they want done. So I think Johnny took offense to that one, Johnny Borsico. But that is something that's come up. I think there's definitely use for channels. Like there are cases where when I've used them, it's been great. Then there's other cases where you see code and it very much feels forced or like a bad way to solve the problem. And I don't know, like, do you think it's because you have people who haven't used concurrency as much and they really just want to use them? Or I guess what's made you feel that way?
Yeah, I think it's mostly that I guess I haven't used that pattern as much in other languages, so it doesn't come as easily. It's a whole, you have to learn a different syntax. You have to learn some kind of edge casey blocking issues that can come up, or just non-obvious blocking issues. And I don't know, just when I've tried to review or talk about the code with other people, it's been more challenging to explain or agree on what's going on. It's not a super informed. Concurrency might be the problem here.
I feel like you're describing concurrency in general. Concurrency, in my opinion, is just hard to explain exactly, in a lot of code at least, if it gets complex at all, concurrency is just hard to reason about. I think that's one of the reasons why so many people struggle with it. Is it's hard to imagine all the different ways something can happen, or I guess the order of execution, because it can be changed so much.
I feel too, a lot of it might be informed by we use Go for web services where you have a very short amount of time to respond to your request. And the most complicated thing you're probably doing in parallel is bunch of requests out in parallel and retrieve the results and do some basic processing of it. And to insert channels into that is usually not worth it, sync, or there's another library we use a lot called Error Group. That's basically can spin up a bunch of stuff in parallel, tell you if any of them errored, and then move on. No channels required, which has been a lot simpler than channel approaches.
Yeah, the error group approach is definitely much, much easier in my experience if you're just spinning up, especially if you, like you said, you just need to communicate with a couple web services and get results. It's so easy to use that it's hard to justify trying to throw channels into the mix at that point.
I can share one if we have time.
We can always make time for an unpopular opinion.
Yeah. Mine is, quote, use the right tool for the job is usually bad advice. And I guess I should explain as well that we used to have this on our job page as something that we think about. But I think the issue I've come to have with this piece of advice, I think, is that it kind of suggests that for every job, you should reevaluate your whole tool set. When in reality, over time, you kind of figure out kind of the contours of the jobs that you repetitively do, and then kind of settle on a set of tools that works for you and the team. So I think there's probably more truth to that advice when you're early on building a team, understanding kind of what are those types of jobs that you're going to be doing a lot of. But once you've settled on a strategy that works for building building HTTP web services that have open API definitions, like you get a lot more benefit in like investing in that strategy and the tools that support it than like reevaluating and changing that, every year. So that's my unpopular opinion, I guess.
It's interesting that you bring that up because, at least in theory, sometimes some engineers will view this microservices architecture and think, oh, one of the benefits is that we can write each service in whatever language is best for it. But in practice, what I've found is basically what you said, that most companies settle on maybe 2 or 3 languages that they use. And going beyond that, there might be one that's like perfect for the job, but introducing a new language there's a big cost to that for the entire company to introduce some new language. And while like Rust might be great for some specific job, that means that somebody on the team now has to understand Rust for like the rest of the life of the company. And that can be an issue, especially like you said, or you were talking about earlier, if you're deploying or something that does get deployed with a bug and it's a big issue, it's like, we don't have time to figure this out. Like we need somebody who knows what's going on.
Yeah, jumping from service to service and like, not being surprised by what you find is huge for productivity. And then, as you invest in tooling to support these approaches, you realize, to introduce a new language or something, you have to build all of that again. And so the bar gets kind of higher and higher in some ways as you get better with a particular set of tools. So yeah, an interesting thing to think about. We've introduced new tools. Like, I don't think this is like saying like, oh, we use Go for everything. Like, for example, Nathan has been doing some like Spark stuff recently, and Go has been like not great for that. And so now we're not using Go for that. And we're introducing some new tools to do kind of this large scale data processing. But for the bread and butter kind of services that we run, the tool set has kind of settled, and we just kind of keep improving it and making it better. So
would you say that's also why, at least I got the impression from what you were saying, that pretty much everything you have is running on AWS, like you don't use other cloud providers? Would you say that's another reason why you kind of stick with just one, is that it's the ecosystem that works for your stuff? So even if somebody has a database or something that's perfect for a project, it's just too much to add something new?
Yeah, I mean, I think database selection is a big thing to think about, because you can try and think, okay, like this problem I'm solving, like is perfectly, you can make a case. I would argue like probably for any database, like this database is like perfectly tailored for this job. But, the vast majority of the time you're going to spend with that database is like having it running in production and operating it. And then like thinking about scale and like if issues arise, and all of those things require tooling, experience, like investment of time and effort in understanding how to run that thing at scale. And once you've climbed that learning curve, that's a lot of work that you should like cash in on and like needlessly rewind the clock and like start it over, unless there's a really compelling reason to do that.
I think that makes sense. To me, use the right tool for the job sounds like the kind of advice that it's almost like advice that isn't actionable, I guess is the way I'd put it. It's like telling somebody, oh, don't do this, but then never actually giving them an alternative. And it's like, well, it seems like you're giving good advice, but if you don't tell them alternative options, they're kind of stuck. Like they don't know how to proceed at that point. So that's probably my biggest issue with that type of advice, is just people do better when you give them something actionable. Or one of those that came up all the time was, I don't know if you've ever looked at, when people build web services, sometimes they'll throw things like the user and other things in a context, with middleware, and then it's available whenever you're inside of the actual handler. And other people say, don't do that. But then they won't say what a good option is otherwise. So it's like, well, what do I do now? Like, what's a good option? And I think that's where a lot of people struggle, is that they need somebody to show them good suggestions for other ways to approach it. Otherwise, it's just really hard to take the advice and use it.
Feels like it comes full circle a little to me too, where, how do you choose to move to Go? Well, is Go the right tool for the job? And I think maybe what's making me think is that advice almost talks more like a trajectory you want to go. You're like, yeah, we want to invest more in like this area, but in any given short-term thing, it's not worth it. So you got to maybe think a little bit bigger about what the right tools for the job are.
Yeah, that definitely makes sense. And how big is Clever at this point?
Usage-wise, we have over 20 million active users on the platform. And then company-wise, this year we'll be at around 200 people and 60 engineers.
Okay. So you're definitely hitting that point where changing things up too much can be very challenging. Whereas like if you're a 2-person team, it's pretty easy to throw something new in there when it's just 2 people.
Right.
All right. Well, thank you both for joining. It was great having you on the show.
Thanks, John.
Yeah, thanks.
And thanks everybody for listening.
You can support our work and help ensure that GoTime continues into the future with a Changelog++ membership. Ditch the ads, get closer to the metal, and directly contribute to all Changelog podcasts at changelog.com/++. Once again, that's changelog.com/++. Check it out. This episode was hosted by John Calhoun, produced by Jared Santo, with music by Breakmaster Cylinder. GoTime is brought to you by our awesome sponsors. Special thanks to Fastly, LaunchDarkly, and Linode. Next up on GoTime, Matt, John, and Chris are talking about code generation with the one and only Brian Kettleson. That episode will be ready for your ear holes next week.